system that we have, if it's a Hadoop cloud implementation or IBM's streaming infrastructure, how do we take the statistical know-how and melt it into that world? These are all exciting challenges, and I'm optimistic we'll make progress. And that's me done. Thank you. Thanks, Mark.
Well, we're changing over and getting ready for our next talk. I thought I would ask if there are any questions for now. Any quick questions? Well,
I'm feeling all. Don't ask me a question.
we'll have a chance for we'll have a panel discussion after the tea break. So don't worry. Keep guys to ask a question now. There'll be a chance to do that. So our next speaker is Giles Pavey from dunnhumby. dunnhumby, if you aren't aware of them, is all about customer insight and understanding. And since I've known Giles, he's become chief scientist and then chief data scientist. And so I'm very curious to hear where you're headed next. Yeah. But I will turn the floor over to you now, and very excited to hear about your perspective.
Thanks, Patrick. Thank you very much for having me. I'm Giles Pavey. The trendiest title I can come up with at the moment is Chief Data Scientist in my company, so that's what I'm going with. I'm here to talk about the problems that we see and we want help with, specifically with regard to big data and what that means for our business, which is mainly working with retailers, but I think it's pretty relevant to lots of businesses. I tend to start off with this slide just because, to me, it really epitomizes what I'm trying to do or what dunnhumby's trying to do. This is Jack Welch, who was the CEO of General Electric in the 80s and 90s. And paraphrasing what he said as to sort of the keys to business, he said the keys to business are to firstly really understand what your customers want, how they're behaving, what they need, what they want to do. And then secondly, to act fast upon that understanding to deliver what they want, what they need, to understand what they're doing. And that's really what we are trying to do, and what dunnhumby has been doing for about the last 25 years, of which I've been with the company now for 16. We're all over the world, working with retailers on lots of different continents. And effectively what we're doing with those retailers is that we are trying to understand what their customers are doing, what their customers want, and then help them work out how to better run their stores, better run their websites, better run their prices, promotions, communications, all that kind of good stuff. Is there a light? I think this is a way that we kind of see business. And I was checking back, and this was a diagram that I first sort of pulled together in 2005. So a company like a Tesco here in the UK, or Macy's in the States, or somebody that we might work with, they've got lots of data, and they've got a load of marketing data and whatever, but they've got this big asset, which is all of their transaction data. And that is large volume data. And from that, what they want to do is unlock the insights. And that's something that dunnhumby's worked with these companies to do, and that we use various computational and statistical techniques to do that. And the point of doing that is to actually change your business. So to change the products that you sell, or the pricing strategy, or the advertising. And you want to change those things in order to have a better customer experience, and then feed that back into your process as better data. Be able to trial and see how things go, to reward loyalty, to test things and change them, and so on. And that was very much the model that drove dunnhumby from the company I joined with, 30 people, to being a company across all of those different locations and with today 3,000 people. But this model is changing, or has changed. And it's changed because of digital advances. Just quickly, some of you might know this book. It was written in 2004, I think, and it was predictions about what digital advances would make for the jobs that people would still do and the jobs that people wouldn't do. And this book predicted that jobs that people would still be doing are ones that are specifically human and didn't suit computers. And two of the examples they gave were translation and driving cars. So I think our ingenuity and the rate of change, and what's the date today? Is it the 7th? So the world has never changed as fast as it does today on the 7th of January 2015, nor will it ever change as slowly. You know, it's just as digital advances are just absolutely colossal. This is my phone. This is my phone. This is it on the telly. It's got 14 sensors on it. Today, every single one of those sensors is being used by different startups to work out in-store locations. So we're working on trials that use, yes, they use the accelerometers and the Wi-Fi. It turns out the magnetometer is a fantastic way of, if you can map out a building, you can get a really good, if there are a lot of metal girders or whatever in the building, you can get a fantastic read on where people are. But this level of information, the Internet of Things, just the colossal increase in data will mean that when we come on to our model of the business has data to drive insights, to drive your actions, to customer behavior, every single part of this is just absolutely exploding. So if you go into a Tesco shop, almost certainly there's one within about 200 to 300 meters of where we're standing, and you go and buy 10 items, you will generate 11 lines of data, one for each of the items you buy, and one to sort of say who you are and you paid with cash and what time it was. If you went and bought those same 10 items online, you'd generate 1,000 lines of data or 10,000 lines of data because of all the clickstream that we're collecting that's generated. So similarly, whether it's the sensors in your phone or whatever else it might be. So massive explosion in data, also a massive explosion in what you can actually do for people. So when we optimize a store, we have to optimize a store to be the best for the people who shop the Goose Street, Tesco, Express. And it has to be the best for the average of the people who shop there. But when we're optimizing the online experience, it can be optimized for every single person who uses it, a different experience for everybody, and it can be optimized for every separate different time they are visiting it. So just massive more opportunities to via digital means, just optimize and make more personal and more relevant the way that you deal up your business. And even in terms of the data that you can understand about how people are liking your services or how they're using them. You know, it's not just what they buy, but it might be, you know, what they are saying about your services on social media. It might be all sorts of different things. So that means that we really need to up our game in terms of the way we generate insights. And that's very much something that, you know, I'm here today to sort of give out as a message of where I think business really needs help from, you know, the academic community on really working on these things. So I've got just half a dozen examples. In terms of, in general, this immediately obvious iconic picture represents the three areas that we really see as being the sort of challenges. So big data and specifically doing things in real time, and not just reporting on what's happened, but actually predicting what's going to happen. So my team within dunnhumby, we sort of use this as a sort of ready reckoner for our work of, is this a big data project? Is it something that's in real time? Is about prediction? And so much of what we now want to do in business ends up including all three. So if we want to give somebody a great recommendation for a product when they arrive, next time they arrive in a store, you know, that's, we might want to bring in data from all sorts of different sources. While we might be able to use some kind of pre-processing to have an opinion on what offer to give somebody, we'll probably want to do some real-time processing of just bringing in, you know, are there any extra filters we want to put in, any extra data we can bring in? Are we sure that that product that we want to promote is actually in stock at that point in time? And so we want to bring in all of these different elements together. And those are some real challenges about both computationally and sort of method, in terms of the method we choose. So in terms of just the sort of new areas we see, for us, we have done really well looking at historic performance, but we need to bring in a lot more prediction. Similarly, we've done really well being able to do our computation in batch, but increasingly we need to be able to deliver in real time. You can't really get much more structured than transactional data from a till, but we need to bring in unstructured data, video, sensors, whatever it might be. We also want to bring in more, rather than just providing insights, we want to build more actual digital products. So a recommendation is a digital product in that it actually delivers something in real time to somebody rather than just sort of gives an insight for the business to act upon. To do that, we see an increased need for machine learning and also the importance of maybe crowdsourcing isn't exactly the right term. We do get involved in sort of crowdsourcing competitions like the Kaggle website that I guess some of you will have heard of. But it's really the notion that however clever you are, there's far more clever people who don't work at your company than do. So how do you have to do partnership, you have to look to bring together great skills. And I can't believe Donald Rumsfeld was the first person to say this, but moving from knowing what we're looking forward to and uncovering things that we didn't even know were there. So what I've got now is far from a exhaustive list, but it's a list of 6 areas where we are actively seeking help in terms of insights and new methods or new approaches. While they're all specific to dunnhumby, I'm sure that many are specific to lots of different businesses. They're not really in any order, and almost certainly we could have written a list of 20. So take as much, I guess, from this in terms of the spirit and the types of things as well as just the actuality. The first one is sampling. I don't know, there's a couple hundred people in this room. I'm sure that you'd be aware that, let's say there's 200. Well, 20 people here will tweet as much as the other 180. And among those 20, 2 will tweet as much as the other 18. So what you have is just increasingly very easily accessible data that's incredibly biased or non-uniform. And so for us, it's a real question is how much importance should you pay to different amounts of data? How do you get a true picture when you can get loads of information, but you know that's only from a biased subset of people? So that's the first area of head scratching for us. The second is forecasting. So every year around the world there are tens, if not hundreds of thousands of new products are launched. And depending on what statistics you read and what sort of time period you look over, somewhere between 60 and 90% of those will fail. They will no longer be for sale. And so if we could, by whatever means, forecast how well a product was going to sell, then there's an amazing amount of inefficiency that could be taken out of the system by being able to cancel products when it was pretty obvious that they weren't any good. Or on the flip side, if you could see that a product actually was really good, you could accelerate it and you could advertise it more or whatever, and you could get good things out there. So that's just one example of forecasting. And of course, there are umpteen, virtually every part of business you can improve by improving your forecast. And almost certainly, there are ways to better use the data that is already captured on sales rates, on repeat rates, on maybe the patterns that we see, let alone the new sort of social media or whatever might be coming on, or ways of correlating between different things, across different types of products or whatever else. So forecasting is a real ripe area for really strong improvement, and specifically from ways of taking and using big data. And potentially also, I guess, ways that you could bring in kind of experimental design to better run your forecasts as well, or your new product launches as well. The third example I've talked about a bit is recommendation. So I guess everybody's familiar with the kind of recommendations that you will see on Amazon. For us, there's an interesting slight difference in the majority of our work is in food rather than non-food items. And the way that the algorithms that run Amazon work is they're typically looking for what products are most closely associated with the thing that you've already bought. But they assume that you're not going to rebuy a 32-inch Panasonic TV if you've just bought one. Whereas it's a fantastically strong indicator that you might be rebuying 250 grams of Marmite if you've bought it before. So for us, the prediction it's interesting in terms of there's a much more of a time element. When will you be up for rebuying something? When will you be? We're actually doing some research at the moment here in UCL with the psychology department about looking at people's attitudes to risk and reward of trying new things rather than sticking with things that they already know and buy. And obviously the fact that we can look at real sort of big data of the transactions of half the population of the UK, or hundreds of millions of people around the world, means that we can actually look for these patterns. And as I think was mentioned by Niall or somebody before, there is an opportunity to bring in other data sources. To be honest, at the moment, all of our attempts it's easy to predict that if it's sunny, that people will buy more ice cream. It's quite hard to predict what the signal to do with the weather is a lot weaker when it comes to the vast majority of items, so it has to be said. And then trying to disentangle the seasonality from the actual weather is another bit of fun and games. So there's lots to be done here. Another area we're really interested in is we've recently started working with a company called Sandtable, who are experts in agent-based modeling. And this idea of building computer simulations with agents working within a computer environment, operating under a set of rules, and then seeing very sort of complex behaviors emerge from very simple rules is an incredibly exciting and interesting area for us. There's so many things that we would love to be able to sort of forecast the results or see what would happen, but you just can't run a physical trial. But to be able to really understand, what might happen through a simulation is very attractive. It's the biggest models that we are currently running have 50,000 agents. It's incredibly computationally intensive to run the models. So that's an area, how can we run those models in a better way? When we do have the models, how can we better look at those models? And then, of course, you can imagine the question that our clients have when we produce a model of, let's say, how people purchase drinks in the UK. They want to say, well, how can I optimize my drinks portfolio or my advertising or whatever it might be? So ways of optimizing across a model, agent-based model, is interesting to us as well. And it's a really interesting field, both sort of computationally and methodologically. Can't say it. Online anomaly detection. So there could be, again, umpteen different examples of why, where this is useful. The examples I've got here are about human behavior, but of course, in any business, there's also the sort of anomaly detection within sort of systems as well. A typical supermarket here in the UK might have an availability of 95%, which means that if you walked in, 95%, or on average, 95% of the things that it should sell, weighted by the sales, would be available to buy. If you flip that around, it means that if you've got a shopping list and you had 8 items on that shopping list, there'd be a 50-50 chance that one of the things that you wanted to buy wasn't in stock. Which is why, if you can improve availability, it's just good for everybody in terms of it's good for the retailer, the manufacturer, and the shopper. And we're definitely of the view that there's opportunity to look at sales rates and maybe some other, data sources to build models to better look for. I guess the anomaly there would be longer than anticipated gaps between sales of a product. Similarly, looking at people's behavior and looking for markers in their behavior that things are going to change. Another area that's increasingly sort of now the data is available when it hasn't been before is looking at networks. So if we think about the example of a social network, the way that how are we doing on time? The way that a social network behaves is incredibly interesting to us. All of us, if we're average, would say that we increasingly don't trust advertising or organizations or governments, and increasingly where we look for and trust is in our own network of peers or friends or whatever else. And this is an incredibly attractive idea in terms of why wouldn't we promote items or get a message out by sending a message out to a subset of people who we knew would really like it, but then ask them to pass on that offer to their friends who they think would like it. The trouble is that businesses are really afraid that that could snowball out of control. And so the ability to be able to estimate the actual reach of an offer, if you passed it out, or a message, if you passed it out to a number of people, and then depending on the message and their influence and their connectiveness, how far would it go? That kind of thing is, again, really attractive to us. So I think that's it for examples. As I say, they're very much just examples of, there's all 6 specific areas that are of interest to us, but I think my main message would be one of they're indicative of the types of things that we are interested in, and the dual challenges of big data, unstructured data, highly variable, and then of that data coming in real time and wanting to do things in real time, in the blink of an eye, are challenges that really mean that we at dunnhumby, but I'm sure across business, are really looking for as much help as we can get. Thanks very much.
Again, time for a quick question while we check it over, if anybody has one. And a reminder that we'll have a panel discussion and time for questions later as well. Any questions? What's up?
Lots of interesting points, but you didn't really say much about the actual methods that you use. And I'm wondering, do you just use the standard methods or are there sort of in-house methods which are commercially competent?
Yeah, of course, I'll find something. Slips in there.
Yeah, we use probably the whole suite of machine learning techniques, and we use more basic from that as well. And an awful lot of is the methods you use to get the data into a fixed state. And then, to be honest, a lot of our more sort of IP-related stuff is about how you actually apply it or what you're trying to do. But definitely, I think our methods, there's a long way that they can be pushed forward. Thanks, Charles.